Good afternoon, everyone. So, welcome to the event on New York City Open Data Week. And this is the first day. And thank you for joining me on the Saturday afternoon. I hope you will enjoy this event. So, a couple of pointers. We are recording this event. So, if you are not very comfortable, then you can switch off your camera. And please maintain the dignity of the event, refrain from using inappropriate language. And I would appreciate if you can mute your microphones. And if you have any questions, you can just write in the chat box. So before we start the actual event, I would like to take the opportunity to introduce ViSER, the company, ViSER started in January 2019 in New York, and it is basically has two segments in which it works. One is to promote STEM, finance, and open data learning among kids and students. And we have been conducting several boot camps, after school classes, enrichment classes for elementary to high school students. And our finance classes were featured in the local newspaper. We have been organizing technology classes and boot camps for adults also. We organized financial literacy classes for women. And recently, we concluded a global event which was called Decoding AI. It was a sponsored event by Association of Computing Machinery to promote AI learning among individuals. And this was one of the events which was selected by ACM. And next is we work with businesses and we provide them data-driven solutions. So we do market research, training, software development, and recently we worked with a Bay Area company, and for that, we filed a patent in IoT chatbots. Now, ViSER is based in South Carolina, and our upcoming events are we will be organizing a summer camp at University of South Carolina for high school and middle school students in data analysis and artificial intelligence. And we are seeking to promote open data in the local government also. This is the link to ViSER website, and this is the email ID. And a little introduction, a small introduction of myself. My name is Vandana Srivastava, and I am the founder and CEO of ViSER LLC. I have two master's degrees, one in MBA in financial management, which I did from Pace University, and then I'm a master's in computational mathematics from Arizona State University. I've been working in both academia and industry for more than 10 years. And I have been vice president. I have worked at IBM as an incentive analyst. I have worked for a long time as assistant professor of mathematics and computer science India. And for 2 years, I was guest faculty at the premier technology institute in India, that is IIT Delhi, the Institute of Technology. Currently, I'm associated with Women Who Code. I'm a guest speaker there, and I'm a panelist. We work we are basically training women for data science track. And this is my LinkedIn profile. Introduce the goal of this workshop. So the goal of this workshop, and I have categorized them in three main parts. And the first is for students or learners of data science or data analysis. So for them, we will be discussing what are the data types, what is data analysis, steps in data analysis. Basically, just to get them feel that what exactly, when we say the data analysis, what exactly happens. So it will be a little introduction, a background of data, what are the software, hardware, and everything. Then the next is for school administrators and teachers who are interested in introducing data science courses to their in their schools or school districts. So we'll discuss how it can be introduced, what are the different prerequisites in terms of hardware, software, and training. And then I have some use cases, and we'll be doing demo, which was definitely, I'm sure all the participants will enjoy working with me. So just to get the feel of how data analysis field works. So the layout of the workshop is in 5 parts. So the first part is before you start data is actually start hands-on working in data analysis. So there are some pre-processing, pre-things which you have to do. Then what exactly is the data analysis process? This is the second part. And then we have data analysis demo. And then we'll look at the different aspects of teaching data analysis, how we are going to do that. And then last is engage with community, how we can engage with community using analysis. So I have this whole event is divided into 5 parts and we'll go through each part. So first part is before we start actually doing data analysis. So what are the different things we need? So these are some tools for data analysis or when we want to analyze any data. And the for most important thing is data. So before you start analyzing anything, we need a problem statement that, okay, which problem are we trying to solve? And first we formulate a problem and then we look for relevant data sets. So this is the first thing which we need for any data analysis project. Next is we have to figure out which programming language are we working with. There are several tools, there are several programming language, but in this particular event, we will be doing it in Python. And I will discuss why Python is being very popular language among data analysts and data scientists. So we have to select a programming language. Then next thing is what will be the programming environment, because programming is needs a certain development environment. So we have to decide on that. So whether we want to work on a cloud, whether you want to work on your machines if you're doing an individual project, or we want to, which development environment is preferred. So you have to decide what kind of different environments or what are the different machines, or these are some things which you have to figure out before we start. Hardware requirements. So there is no fixed hardware requirements, but when you are working on Mac or whether you are working on Windows or whether you are working on Linux, you have different ways to approach the problem, because you will be there will be slight difference when you are downloading the software or when you are working. So there will be slight differences, and if whether you are using Chromebooks. So this is something which you have to decide before you start dealing with a data analysis project. Training. What are the things which are required before you actually start the data analysis? Okay, so do you require any training? Do you need any certifications, or do you need any particular qualifications before you start a project? So let's explore all these tools one by one. And I will start with giving a little bit background, because when we are doing the demo, I want everyone to be on the same platform, able to understand at least the basics of this project which we are doing. So I'm going to introduce basics about data. What exactly is data? So it's a set of observations which are collected together. Okay, so it can be in the form of a table, or it can be how it totally depends on how you organize it. But generally, most preferred way is to organize it in a table, basically a set of observations. So, for example, this is a New York City open data on water consumption in New York City water supply system. And this is I have given a snapshot of this data set. It's a very simple data set with 4 columns and multiple rows. So this gives you a glimpse of what exactly is data. It's mainly a set of observations. So these are most preferred. There are multiple ways of storing your data, and CSV comma separated values. It's a most popular, very easy to store, very simple to use. So this is a very popular way of storing your data. And then there are other formats also, like text, PDF, JSON, XML. We will be working on a comma separated files, because all the New York City open the data sets can be downloaded in different formats. And I find CSV to be the easiest one. So we will be working on that. Then your data can be in the form of, it can be a text, it can be sound, image. There can be multiple data sets. So this is again the basic of data, that what kind different types of data is there. We categorize them into two main parts. One is qualitative, or it is also called the categorical data. Like we are describing any the temperature, so let's say it's hot, cold, or if we are defining the regions, Asia, Europe, so anything that has text in it, it's basically category or quality of the column. Next is the quantitative data sets. So as the name says, quantitative, that means it has to do something with the numbers. It's also called numerical data set. So like 2, 3, all the numbers, the decimal numbers or the whole numbers, all these are called numerical data. Now, numerical data is of two types. One is discrete, when we are talking about whole numbers like 1, 2, 3, 4, no decimals. They are also called integers. And then we have continuous numbers like decimals. Whether they are positive or negative, it doesn't matter. They are also called continuous data. And in programming terms, they are basically referred to as data types in like integer. So a discrete data type is called integer or int. String is str, and it is used to represent string or text. Floats are used to represent decimal numbers. And Boolean, we will not be dealing with Boolean data set today, but Boolean means true, false. These are the four basic data types in Python, and you will know more about when we are dealing with an actual data set. So another thing that is very important is programming language, and these are some of the reasons why we use Python. It's a very popular programming language for data analysis. That is why we use, and let's explore why is it very popular. It's open source, that means it's freely available. Anybody can download it. So this is freely available. It's very easy to use and simple to understand because most of the syntax comes from the English language. So if you just take a look at the different functions, you will be able to understand why is it being used or what is the functionality, what is the usage. So that's the best part because it's the function names are very similar to the English meaning. Python is full of data handling and visualization packages. So instead of you writing 10 lines of code and getting a very, just to get a very small work done, instead you can just call those packages, use them in your program, and it's just a one line of code. So that's why it's very, very easy to use, it is easy to understand. And Python is full of, you can call them packages, libraries, modules. It's full of, it has many functionalities. So that is why it's very popular. So you just need less lines of code to get the desired output. So these are some of the major reasons why we use Python. So before we start seeing the demo, and so let me give you some definitions which are related to Python, which we will be mentioning when we see the demo. Data frame. So a data frame is a two-dimensional structure. And as you can see on the right-hand side, you are seeing there is a rows and it contains columns, and this is the data. So it has three principal components. Main is data, the rectangular 2D structure, and it consists of rows and columns. One thing I would like to mention here is when you are doing Python programming, and if you want to refer to any column or any particular row, so the index, because there are a couple of ways in which we access data by rows or by columns. And Python starts indexing from 0. So your first column will be, if you start by index, it will be referred to as 0th column. Similarly, first row will be referred to as 0th row. So these are some of the things, but we may not be needing them in today's project, but this is something worth. Next is we are going to use Pandas library. Now, Pandas is a library which is full of functions that are used for data analysis. And that is why it is a very rich in functions library. And you will see that how just by writing one line of code, we can do multiple analysis at the same time, just by writing one line of code. So it has, I won't go into too much detail, but Pandas is a library which we will be using, and it's used for data manipulation, data analysis. So this is worth knowing. Okay. So let's talk about the most popular programming environment. And one is Jupyter Notebook. It's an open source web application, and it comes bundled with Anaconda distribution. So it's basically a programming environment where it's like a text notepad. So you will be using this, we'll be doing it online. It's used very much by data analyst and data scientist because of its ease to use. So the best part is it comes, many of the Python packages comes already installed in there. So they are already there as they comes as default packages. So Pandas, you don't have to install it. It's already there. You just have to call those packages. So you will see that how simple it is use. It is very easy to debug also, because it's the whole text area is divided into different cells, and you can write a specific work can be carried out in one cell, and we can always refer back to the cells. You can always edit the cells. So it's very convenient to work it. It's very convenient to debug using Jupyter, and you can work both online and offline. Generally, we prefer, if we are working on our machines, we prefer Jupyter Notebook. There is another very popular uh, environment, which is called Google Colab, and it's a Google Collaboratory. It's again free. It's a free cloud service. So you just need a Google account, and it's very much its working is very much similar to Jupyter Notebooks. So whatever files, if you want to work on cloud, you can share all those files. So the Jupyter Notebook files can be opened in Google Colab also and edited. So you don't have to worry about that. Okay, if I'm working in Jupyter Notebook, how can I use Google Colab and so on? And if it's in a cloud, you're using Google Colab, you can always share your work. So these are the hardware requirements. Any operating system can be used. So you can do programming if you are learning or you are teaching. Any kind of operating system can be used, whether it's a Windows, a Mac, or Linux. Now we don't, tablets are not preferred for programming, especially you cannot do programming if you want to work on your machine. So if you want to work on cloud or you want to do it online, you can do it, but generally it's not preferred. And hardware requirements, no high hardware requirements if we are working on a small to moderate data sets. So that is the best part, because if you can see all these 3 points, we don't see any very high demand or high requirement or very strict requirement of hardware. So what is the training required for any age group, especially for the middle school and above? Because this particular event is targeted for middle school and above students and adults. You just need a problem solving mindset and basic knowledge of mathematical and statistical concepts, because for analysis and to interpret the results, we should know about the different kinds of charts, what are the different kinds of mathematical operators are there, or what are the different usages of operators. So it's important that a basic knowledge is required, but definitely It's not something that cannot be taught, because during the process of data analysis, we can always teach students some basics about these math and statistical and their interpretation. Otherwise, it's not a very hard requirement. So what exactly is data analysis process? When we say we did a data analysis or we are doing a project, what does it mean by that? What are the different steps we have to carry out? So with data analysis is not a single, it's basically a collection of steps. And we start with defining what exactly is data analysis. So data analysis is basically you process your data, and from the raw data, from the meaningless data, or from a collection of observations, you are trying to find patterns, or you are trying to find any meaningful information. So so that is why we do analysis, because if we just take a look at the numbers, they don't give us any information. But if we do some steps, or if we do some processing, and we do we apply some technology, we start getting results, and then data starts getting meaningful. So in nutshell, we can identify and analyze and interpret trends or patterns in complex data sets. Okay, so that is called data analysis, when we try to get the meaningful information from unstructured data or meaningless data. So these are the steps which has to you have to do it, and it's this is a process, so it has several steps. First is data reading. So when you are doing a data analysis, you have formulated your problem. So as I said, first you have to start formulating a problem. So I'm assuming that we have a problem in hand, and we have data in hand. So that part is taken care of, and then now comes the data analysis part. So the first step is data read. So we want to read the data in our program, and for that we have to import necessary packages, and sometimes we have to install new packages also. So pandas library, luckily pandas and the plotting software package like matplotlib in Python, they are already installed. They come bundled with Jupyter Notebook or Google Colab. But when you are doing something very specific, then you have to install it. So depending on the kind of analysis and the use, we may have to install also new packages. But if we are doing a simple data analysis, just by importing or calling the pandas library or plotting library like matplotlib, it's enough to start data analysis. So first thing is data reading. And for that, we use pandas, and we make a data frame. That means whatever data which is, whether it is in CSV or any other format, we want to store it in our program as data frame. And we have to, this is called loading data set in program. For that, we need pandas library. Step 2 is data exploration. So sometimes if a data set is very small, then there is no problem. You can open the data set, and you can just scan it. But in most of the cases, it's always a good practice. You do data exploration, and data exploration is a very, very important part of the data analysis, because it gives you overall feel of the data. So that what kind of data set is there. And I have given some examples. Some of them, data exploration means you want to know about the column names. You want to know how many how many rows and columns are there. You want to know the summary statistic. That means the mean, median, and the count, maximum, minimum values of each and every column. You may want to find if are there any missing values, because this is a very important part of your analysis, and it has to be dealt with in actually a appropriate way, because data exploration, if you have data, missing data, whether you want to delete that data or you want to keep it, or how you are going to handle it. So for that, you have to first find out if my data set has missing values. Is my data duplicated? So that is also part of data exploration. Then how will you access, what are the data types of your columns? That means whether it's numerical data, categorical data, or whether it's float. So basically numerical and categorical, or whether it's an integer or float. So you may want to explore that. And why is it important? We'll see when we are doing this demo. Also, you may want to know the name of all the columns, and you may want to access the, the data in a particular column. You may want to see how the typical, how my data set looks like. So these are some of the things which we, which is basically a part. It's not a comprehensive list, but it just gives you an idea that what goes into data exploration. And definitely all these things changes. The steps will remain fixed. You have to do it, but you depending on the kind of data or the problem you are solving, some of the steps you may not want to do it, or some of the steps are not needed. But data exploration is important part, and it's the first. I would say that this is the it's an important step toward your correct or good data analysis. Now, data cleaning. So you have explored your data set. Now you found that there are some problems with my data. How will you handle? So this is the part of data cleaning, like handling missing values or handling duplicate data. Definitely for good analysis, you may want to delete the duplicate data. So how will you do it? Or if you have missing values, will you delete the rows with missing values, or you will delete that column, or what you are going to do? Or you may want to substitute the missing values with 0, or you may want to substitute the missing values with the average of that particular column. So that is where we do the data cleaning. And also data cleaning is if there are any problems with column names or the data type of the column, then it makes sense to do a data cleaning, because we don't want to proceed with a corrupt data, because that's going to affect the analysis and we are not going to get the correct results. Now comes the part where we actually start analyzing the data. So let's see what is there. Now we are going to, if you recall, I said when we start doing the data analysis, and before data analysis step was one of the important steps was you formulate some questions, you formulate some problems which you want to solve and which you want to get the answers. So we have to in order to get those answers, we have to use appropriate functions. And for that, you have to be familiar with what will be a relevant functions. So let's assume that you have found answers to your questions, you have done data analysis, you got some answers. Now, next is a very interesting and very popular data visualization. So you have your data, you have your results. Now you want to present those results in a way that catches their attention. And you don't have to uh, take time to explain your results. So the best way to do is visualize. That means create charts, graphs for your data sets. And Python has a rich library of graph, and that is called matplotlib. Even with pandas, you can make basic charts, and I will show you how to do it. So visualization is a very interesting part, and here you can use different plotting functions. Apart from matplotlib, there are several other Python packages which are very popular, very interactive, and very, you can draw beautiful graphs. And a different kind of charts with them. And one of them is Bokeh, Plotly, and Seaborn. So these are some of the visualization packages which can be used in Python. And next and the last step is result interpretation, or making a report, summarizing your observations. So you start with you start with a data that was just a bunch of numbers, bunch of text. Now you followed some steps, and now is the time to see the results. So this is interpretation is very important. For that, you have to have a certain level of understanding, and result interpretation should be related to the original problem. You may do a lot different kind of analysis, you may perform different functions, you may get different results, but not all the results may be relevant to the questions which you are trying to answer. So make sure you interpret your results correctly. This is very important. Or while analyzing the data set, don't just follow all the functions, or don't use all the functions. Just try to be focused on the functions which answer your questions. Now, in all these steps, you can always, because this is a very interesting process. So it's quite possible that when you start doing analysis, you may start getting very interesting results, and then you may want to change your questions, or you may want to modify, you may want to add some more questions. So this is something which we can always go back to the first original thing, that is what are the questions we are trying to answer. And so this is where the last step, and that concludes the data analysis. So these are the 6 steps which goes into analyzing data. So let's do a data analysis, and it's basically New York City OpenData set. It's a very simple data set. It's natural gas consumption in New York City in 2010. So I'm going to share both the Jupyter notebook file as well as the data file, and I'm going to share it with you. Let's see if it's shared. So so I hope the link is shared, where you will find the Jupyter notebook as well as you will find the data file. And I'm going to show it to you I'm going to do a demo. So I want you to follow, just give me a second. So I want you to all to follow this link which says jupyter.org/try, because we are going to do it on the online Jupyter platform. So just click this link, or you can just search Jupyter. So Jupyter, and just open this link, and before we proceed, and what you can do, the 2 files which we have shared, can you save it on your desktop so that we can, and then from there we are going to upload it on our Jupyter platform. Okay, so let me give you an introduction of what data set is this. So this is a link to the data set which I am using. It's by Mayor's Office of Sustainability. And it is a data set which gives the natural gas consumption in terms of therms, which is a energy consumption unit, and gigajoule, GJ, by zip code and by building type, and then the utility company, the utility provider. So this is a snapshot of the data set which we will be using. And I am trying to answer these three questions. What is the total? What was the total consumption in gigajoules? So I'm not using therms. I'm using gigajoules. So I'm using this column. So we will be interested in this column, the data in this column. And then what is the total consumption in gigajoule by building type? So I want to know what are the different building types use, how much natural gas they are consuming. So I will be using this. And then which are the different zip codes? I want to find out which zip code is using uh, how much natural gas. So these are the simple three questions which we want to answer. So let's, before we proceed, once again, I am giving you the link. So just either you can do Jupyter Online, you can search Jupyter Online and you will see Project Jupyter, try Jupyter, Jupyter Notebook. The link is given here, jupyter.org/try. And then from here, I'll tell you how we are going to do it. So let me stop this share and I'm going to start. So if you come to this site, jupyter.org/try, you will see this kind of, you will see this page. And we are going to do try classic notebook. Okay. So I'll answer your questions in the end. So let's start classic notebook. So it's going to take a couple of minutes depending on because we are doing it online, so based on the network. So after you click try classic notebook, you will get something like, and what I'm going to do, I'm going to click, if you're following my cursor, I'm going to click this file and I'm going to do this open notebook, new notebook, Python 3. Okay, now I will do this open because I'm assuming that you all have downloaded this in your, so I'm going to open. And if you do open, don't right now, don't do the new. If you see open, on the right hand side, you will see one option which says upload. And if you see upload, wherever you have saved your file, so I'm going to upload the two files. One is my Jupyter file, which I have shared with you, and the another is the data file. Okay. So I'm going to upload these two files and I will say open, and I'm going to get this option. So I'm going to say upload and then again upload. So these files are already there, and you can just run it with me just to see how this is going to work. So I'm going to open this IPYNB, and this is the programming file so first step is reading data. So I will go with it. So we are going to install one package here because I find this package really interesting and I will be using it. So just write this command, or you can so if you are using any package, which is, if you have Jupyter already on your system, you can use it. So I'm going to use this, I'm going to run this and I'm making it, I will show it to you in another notebook. So the first step is reading necessary package. And as you can see, reading data. And the first thing is we are importing the necessary package. And since pandas is already there, so we don't have to install it. So we just have to import it. So so I click this cell, and then if you take a look at the topmost, so you look at this button which says run. I'm going to so this cell has already completed running. Now we want to read the data. So again, I click the next cell and I said run. So if you take a look at this is the syntax. Syntax means that is how we load the data set in a data frame that is called data. So data frame, I have already mentioned during this in the slides that what exactly is a data frame. So whatever feature, so before we do it, let me show you the actual file. And this is the actual file. So as you can see, it's a comma separated file, and we have several rows. It's basically all the data points are separated by a comma. So so make sure you have the correct name of the file. And there is a function in pandas which is read underscore CSV. So we are calling that function, and that is used. It reads the data from the data set with the name given in the parentheses. And then it stores the data set as a data frame. And we are calling this data frame as data. Okay, so this is the first step, reading the data. And, or you can say loading the data set. Now my data frame is ready. Now I can use this data frame to start using different functions. So the first thing is we want to see how my data looks like. So I want to play first 5 rows. Now head is a function of pandas, which if you don't give any value, if I say head 10, so it's going to give me first 10 rows. Okay, first 10 rows of data. But if I don't write anything and run it, it gives me default is 5 rows. So you can see the 5 rows of data set. Okay, so this is reading data just to make sure that, okay, your data set is being read correctly by the Python or by the pandas. So you just see this. Now comes the next step, and that is called data exploration. So I will show you some small data functions exploration. So one is shape. Shapes give you the number, the function shape gives you the number of rows and columns in your data. So if you run it with me, it says 1015 rows and 5 columns. Okay, so you know how big is my data set. Now I want to know the names of the column. So I call this the columns function. And if I run it, I get the names of the columns. Now, why is it important? Uh, when you have too many columns, then it may not make sense to know about all the column names. But since this is a small data set, I want to know the names of the columns, because if I want to access any column, I have to make sure that I access my columns with the correct column name. In case I miss anything or I misspelled anything, the program is going to give me errors. So it's always, I find it really helpful if I print the names of the column. Now, next thing which is really important is I want to know the different data types. Now, pandas can make mistakes in identifying the data type of the column. We looked at the data, as you can see, zip code. Zip code is something which is it's a text basically, but the text represented as numbers. But building type is a text, which is fine. Consumption, as you can see, it's a floating point numbers, and the consumption in gigajoules is also floating point numbers, decimal numbers. Utility is also a text. Now, as you can see, the column names were printed. Now, if you do data D types, we get the data types of different columns. Now, here you can see float, consumption in therms and gigajoule. They are correctly identified. Okay, and float. But what is this object? Now, if we have in basically pandas identify object data type as if there is a string and with combination of some alphanumeric characters like underscore or something. So it mostly identifies string as object. But sometimes if you're doing any string manipulation, you may want to change it into a string. So that is something which you have to be uh, very cautious about, because if you want to answer some questions which need your data, column data type to be numeric, and somehow the uh, data type that is being identified by pandas as object, then it's not going to find the total, or it won't be able to do any mathematical operations. Okay, so that is something you have to be, yeah. So please don't import just attribute error. No, it's going to give you because it's not already installed. I will show it to you how we can use it, but just comment it out. And in Python, the comments are given by using a hash sign. If you put a hash sign in front of any line, it becomes a comment. So just leave it pandas profiling. I will show it to you, but so just leave it as it is. So don't do the profile report. Now, next is I found out, okay, now this is something, now I found out when I was using this, when I was doing data analysis on this particular notebook, I found out that the names of these columns, the names of these columns are can create problems because they have spaces in between. There is a misspelled name. And so what these are the things which we have to be very careful about. That is why it's good to print the columns names. So let's do data cleaning, because this is something which can be taken care of in data cleaning. So I found the column names to be, first of all, they are very big, and then they had some parentheses, and then they had spaces in between. So I decided to rename my columns. And there is a function again in pandas where you can rename your columns, and this is the syntax. So this is the syntax which you can use. So I am doing the zip space code because the spaces can create sometimes problem, and it's becomes a problem to access the data set. So, so I have changed zip code to zip, building type, and then I have just deleted that, the service class and something, and I have converted into building type and so on. So I'm going to run this, and I just want to see if my column names have changed. So data.columns again used to access the names of the columns, and as you can see, my column names have changed. Now you have to be very careful. If I write the column names as this, because I faced this problem, so I thought it's interesting to show it to you. So as you can see, while column change, I did this, okay? And then I tried to run it. So it didn't change so I was having problem in getting the names changed, okay? Now I'm getting the names changed because it's already in the memory of data, so it's not doing it. But you have to make sure that there should not be any uh, error in writing the original column names. Otherwise, you are going to get errors and you are not going to get the desired output. So make sure column names are correct. Next thing, I wanted to print out what are the different levels, or what are the different building types. So I said, okay, what are the unique building types that are mentioned in the data? So so what did I do? Now this is the first part. The first part The first part of this is accessing your columns. So this is how we access the columns in pandas. So we write the name of the data frame, that is data, and then we write a square brackets. We put a square brackets, and inside those square brackets, we write the name of the column in quotes. Okay, it can be a single quote, it can be a double quote, because the strings are represented by either a single quote or double quote in Python. So this is how we access the column name. So what we are trying to achieve in this particular line of code, we are saying that, okay, go to that particular column, okay, and then try find out what are the different unique types defined. Okay, and as you can see, there are 6 types of buildings. But when I looked at this result, I found out that there is a large residential represented. Residential is written in lowercase r, and there is another category which is written in the same category, written in uppercase r and lowercase r. Now, this can be a error in data entry. Okay. So I decided that, okay, both of them represent the same categories, but somehow since they are spelled differently, so Pandas is treating them as different categories. So now again, data cleaning comes into picture. So I decided to rename. I decided to I made sure that my spelling of all my lowercase r starting residential starting with lowercase r, and in especially in large, they are written as lowercase. So I said, okay, find the string, sorry. Now I made a copy because I didn't want to touch the main data's frame. Okay, so I made a copy of it. If you want, if you think that you are not going to use it, the original data set, you may keep on doing it with the same data. But I thought maybe it's something which is relevant for my analysis. So I copied this into another data frame, which is data 1. And then I said, okay, the column building type in the new data frame. So this becomes my left-hand side. So this becomes my left-hand side because I want to make changes in only the new column of new data frame. So because we are worried about this column only. So look at this original, this particular column. Find the string. So str.replace is used to replace. And what you have to replace? You have to replace large residential with a small r with large residential with a uppercase r. So I made that replacement. Now, this is something which again, which is going to help me because then otherwise there will be error in my data analysis. So now I run this program. And then again, I ask this function unique so that, so now you can see we only have 6 categories. So this ambiguity or the difference in uppercase R and lowercase r, this has been taken care of. Okay, so we just remove. Now we could have done the missing values also, but I will show it to you. If you use the profile report, you will see there are a couple of missing values also, which can, in such a data, it was a small data set, so I didn't feel like removing those data or values, or so I said I kept them as it is. Now comes the data analysis part. So I want these 3 questions to be answered, and as you can see, we have already discussed what are the 3 questions that needs to be answered. So I want to know the total total consumption in 2010 across all buildings, zip codes. So I want just the final number. And final number is you just, I'm going to use a function that is called group by. So this is a group by function. This is very, very important and very useful function for data analysis because you can do a cross-sectional data analysis. And the examples which we are going to do will show how it is done. Now I am saying I want to, so total consumption, you just have to use the sum function. For doing a cross-sectional data analysis, I'm going to use this group by function. And what was my question? I want to group by buildings types because I want to know the building type. So the result which I want is building type and then building type. And then I want to know how much consumption for each building type. So I want the total of it. So I'm going to use this group by function. So first argument is basically the category by which we want to group, and then what we want to group, and then whether we want to get the total or we want to sort them or whatever is there, whatever we want to do. Since we want to know the total, so I'm adding all of them. Now I want to print these results. So as you can see, I am printing these results. So let me. So this is something, this is the result which you got. So in gigajoules, you can see for commercial, it's close to 99 million gigajoules and so on. So this gives you the different values by building type. Now next is I want to know by zip. So again, it's very simple. I want to do it by zip. So I put a zip in the first parentheses. And then what I want to get the total of, I'm going to find the total consumption in gigajoule. And then I want to add. So it's similar as we did in the previous one. Just there is just a change in the categories by which we want to sum. And if I run it, you can see the results. Now, Pandas has somehow, with the zip code, they have given you the latitude and longitude. So you don't have to worry about it. So this is something which you got. And you can see there are 231 zip codes because length of this data frame which you have got is 231 length. So that means there are 231 zip codes and these are the different values. Now you can sort this data frame by increasing value, by decreasing value. So you can do a lot of, you can do further analysis with this set also. That, okay, which was a zip code which has the minimum number amount of consumption and so on, or maximum, or what was the average. So you can further analyze this data set. And you can always, the best part is we can always add more functions after sum. Okay, so you can, this is the best part about pandas, and that you can just by a single code, you can do achieve a lot of different functionalities. So you can further refine your analysis. If you want, you can add more functions to it. Now comes the data visualization. So I got this data set and it's in a tabular form. So tabular form is not very attractive, neither it's easy to understand. So it's always a good thing that you make visualizations in your, or charts in your particular data analysis, because it's easier to explain charts rather than explaining it in a table. So I have made this chart. Now I am using Pandas plotting capability, but even then you have to, the best part about Pandas chart making capability is that you can just take the data frame and you can right away make a chart. Okay, so as you can see, I have saved the results because I've made this chart. So if you can see on the first line, I have defined another data frame, sum underscore usage underscore building, where I am saving the results in a data frame of the analysis which I have done about building type. Okay, so I have saved it, and that is what I am using it here. So I'm right away, I am using this building data frame, and then I'm using this plot, and there the syntax may be different because there are a couple of ways to do the achieve the same result. And then I have said, okay, make bar graphs because they are very easy to understand. And then you can change the colors. And this is not all. There are a lot of things which you can make customization to your charts. You can do a lot of changes. You can add, delete, whatever you want to do. There's a lot of customization available. So as you can see, this graph, and now it's clearly visible that industrial building type has the least, they consumed the least amount of natural gas. Okay, so this is, and the maximum is commercial. So this is an interesting thing. Now, whatever analysis you did in the first part, it's now very visible. Clearly, you don't even have to explain it to anybody else. Now, the interpretation, further you can do why this happened, but this is something which can be explored further, but this is the analysis result. Okay, so I have taken a simple data set and I've tried to give you an overview of the different steps that you carry out or you do when you are doing data analysis. Now, there are many other things. Definitely, we can, if for each step, we can go explore further, dive deep. But this is overview which I wanted to give. So let me come back to my PowerPoints and let's start. Now, this is a project. I will go over a similar kind of project that was done by students of ViSER. And because we have used New York City OpenData a lot to teach data analysis to high school and middle school students as well as adults. So this is a project. I will just take you through the report. So we'll quickly go over this. And this is a data set which is leading causes of death. And this will give you a sneak peek into what kind of reports that is prepared when you are done with your data analysis. Just a glimpse of the report. It's new between 2007 to 2014, the leading causes of death. So this is the metadata, the information about the data set which we used. Link is given, and the data set is by gender and ethnicity in New York City from 2007 to 2014. And it had 1094 columns, rows and 7 columns. These are the names of the columns. And we had, this is a very interesting data set because it had missing values at last 3 columns, which was aged. Just I'll give you a snapshot and you will see. And the interesting part was the missing values were represented as dots, not the places were not left empty, and those were numerical columns. So we had to do a lot of data cleaning just to make sure that we have the correct data type, because Pandas was giving that data type as object data type, and we had to do a lot of math on this, which we were not able to do. So then we have to run the process of changing the data type of the column. So this was, so as you can see, the last 3 data columns are deaths, death rate. I have focused mainly on the deaths, and then we saw there were many empty columns. So Again, data cleaning was very important for this particular data set. Missing values were represented as dots, and column names were very big. The disease leading causes of death, the causes were very long. So this was something very unique part of the data set. But it was easy to understand. And as I mentioned earlier, we had to go through the process of converting numeric data from object to numeric. So the people died were close to 425,000. There were 26 unique causes of deaths from 2007 to 2014. And this is the yearly number from 2007 to 2014 in a tabular form. This is by race and ethnicity. And as you can see, you can do the comparison because there is a table and there is a chart. And as you can see, table, it's catchy as well as it's very easy to understand this particular chart rather than looking at the table. So as you can see, white non-Hispanics, maximum deaths, and there were the minimum were where there is no mention. Leading causes, the topmost cause was disease of heart. Okay, and these are the top 5 causes by number of deaths. This is by, you can do the comparison every year by gender. So males and females. And the interpretation is an observation, or we can say that more females died than males. And the difference throughout this 8 years, it was almost constant, close to 1,000. Another view is you can do the comparison here also, males between males and females. And what was the gender distribution? So from the total, you can see the blue part represent the females, and orange represents the males. So in 2007, the total deaths, as you can see, it's clearly visible from just the graph that it's almost equal. The number of deaths between male and females, it's almost equal. So what did we find? The interesting observations. So just to summarize them, heart disease is the primary causes, and the surprising thing is more females died of heart disease every year than males. So this is something which can be recommended because that means if we are preparing this report for any action item, then this is the action that can be taken, because concerned authorities should create awareness among females, because this is surprising to see more females are dying by from heart disease. So these are the summary recommendations. So let's come to the part 4, and that is how to do if you are doing teaching or learning. Okay, so let's go over that part. So before that, we have to realize the importance of data science education. So results are fact-based. Okay, this is not, they are free of human biases, and you can always reproduce those results. So if you are using the same data set, then anybody can do the same analysis and get the same results. So that is something very important. It helps make better decisions. Next is, we all know that in future, there are so many data science jobs that will be upcoming. And it's this, the jobs will continue to grow, and they are going to grow at a very high pace. So this is something which should be considered. That's why it's very good to introduce data science, to introduce data science or data analysis. Just to introduce them at an early age is very important. Then it gives opportunity to solve real world problems because of this open data at different levels by different organizations. There is no deficiency, or there is no problem in getting data. So you can always contribute to solve real world problems. And many a times this can be monetized because many people have created apps, and from those apps they have using this particular data sets or open data, people have created apps. So not only that those apps are benefiting society, or those apps are creating a lot of awareness, as well as they are helping people earn some money also. Now, another thing which is important is what kind of data set, if you are starting to teach or if you are learning, what kind of data set should we choose when we are starting? Definitely, especially when you are starting. My recommendation is begin with a small data set. Like I showed to you that water consumption in New York City, it was a very small data set, let's say 50 rows and 3 or 4 columns. Basically, what happens is sometimes when you are not confident that my results are getting correct, okay, this is one way of checking, because you can do manually check everything and see if you are getting the correct results. So it's a recommendation. It's not something you have to follow, but it's good to start with a smaller data set so that the concepts can be verified. It's always good to start with a smaller data set. Another, which is from my experience, data sets should be understandable and exciting to the audience. So I was teaching this course, I have taught this data analysis course to elementary school kids, high school kids, and adults. So for elementary school kids, for example, I chose the avocado data prices data set. Now it was a very simple data set. Kids can identify all the columns. They can understand all the columns because it had prices, it has how many bags, what is the price of one avocado, and so on. Similarly, we use New York City leading causes of death for helping for doing a project with higher level school kids. And we did this with adults also. Similarly, as an example, I was using teaching data analysis to adults, and then we took the stock prices. So this is something which made adults excited because they can see their stock fluctuation and over the time and other things which can be done. So financial data sets can be useful for adults. How can it be taught? So in schools, workshops can be conducted, or it can be a part of after school programs, clubs. It can be added in curriculum also. And one of the uh, important points which I realized is if we can create awareness among parents, if we involve parents and make them aware of the different options available to learn data science, and also what is the importance of uh, having your kid learn this particular trait or skill. So this is something which can be done. And if you are an individual who want to switch to data science track, or if you are interested in doing it and you want to start, so there are more than enough options available online, which are free, of course. You can audit it. They are some are paid also. So you can take online courses. They are self-paced. So I have given some examples. And then either attending webinars or short-term classes. So we were conducting boot camps for adults, and more, if not boot camps, we conduct 6 to 8 weeks classes where we teach from Python programming to do a analysis, to learn analysis. So 6 to 8 weeks are, I find them enough. And we always give students resources so that if they are interested, they can always proceed further and they can take it forward. And there are so many free webinars available where you can learn this particular data science from basics to advanced. You can learn everything. What are the prerequisites? So in my experience, as I told you, that you need mathematical and statistical concepts. So basic, which can be taught if generally middle school and high school students are already aware of the math and stats, the basics which we do and use in data analysis. And if we talk about programming language, data analysis and programming language can be taught together. So we spent 2 or 3 classes just to get students in the mode of logical thinking. Okay, and how programming, what exactly is programming? Well, it's basically a sequence of steps, logical steps. And then from there, they start doing the data analysis. So this is not something which is very complicated, which can be done while you are giving the tools of data science. The best part is most of the softwares are freely available. So we just need a computer to work on. We need a machine. Otherwise, resources are already there. And the best part is they are free. If we don't have any machine to work on, then there is always an option to work on cloud. But sometimes working on cloud, if you can work on Google Cloud, that is always a good option because you can save it in Google Drive. You can save your programs in Google Drive. So that is something which is very interesting from Google Colab. And there are too many websites which provide the interface for doing programmings online. So there is no hurdle to start working on data. Chromebooks, because in schools generally public schools provide Chromebooks. So although if you are working, it's not preferred to work on Chromebooks, but if you are working online, then it's not a hurdle. So that's something which can be taken into account if a school is trying to introduce data science education in the school. Why NYC Open Data? I'm sure most of our audience know about that, but from the point of view of teaching, as we know, Open Data there is no legal hassles. We can always reuse it, reproduce it as in the way as we want. Next thing is they have a wide variety of data sets, multiple categories. So it can be used to cater any kind of age group you want. The size of the data sets are from very small to very big. And from very big parking violations data, I was working on it. It's almost close to 25 GB. So it totally depends on what kind of problem you want to do. So they have everything. And data sets are reliable because data sets are coming from government sources, from reliable sources. So this is something which basically adds credibility to the data and easy to download and work. So we never had any issues in downloading it. So that is another plus point for working with this data, New York City Open Data. And also it promotes or it motivates user to engage with community. This is a very nice way of engaging with community, and which can be achieved by using the open data sets. Scope of data analysis education, definitely it's not something which can you can restrict to classroom. You can always make apps. So there is do a lot of projects. You can get answers to a lot of problems, and you can always present those results. You can always share those results with people. So the scope is unlimited. And some of the projects, just to give you a feel that how open data can help, is basically these are the some of the projects which I found very interesting on the New York City Open Data page projects. And people have used open data, the people and companies have used their data sets to get some very interesting insights. And some of them are this. This is a very, the last one is interactive visualization of New York City street trees. So if you want to explore more, you can just go and take a look at their projects. So you can see the way you can engage with community just by using the New York City open data sets. Now, in this particular slide, I would like to share my experience while teaching data analysis. And this is what ViSER's experience, you can say that. So this was the biggest challenge we faced. And it was because every student in our class had their machines, and they had diverse operating systems as well as different versions. So installing software to work on local host, not on cloud. Local host means on their machines. That was the biggest challenge. And it took most of the time. But if you are using it in your computer lab, everything will be there, so it won't be a problem. And this is something which I found out a lot of syntax errors, because the participants were so excited to do programming. And so syntax error is something which you have to, this is a challenge which we have to take care of in the first few classes. So this is something which is very common. This is not something which somebody should be scared of. Syntax error, if anybody doesn't know what exactly is syntax error is basically the programming rules which we have to follow when we are writing the code. Another thing is curriculum should be flexible and it should be customized to the audience. Even if we are teaching high school students, the set of the students can be, each set of the students can be different. So I personally preferred customizing in detail to the kind of audience I was catering. And that is why the curriculum should be very flexible. We have to make sure that whatever we lesson plans we make, there should be a scope of flexible customization. Kids, they got very excited to see the results of analysis. So finding the sum and finding the maximum value, minimum value, they were really excited to see getting the results in just few seconds. And they love to learn programming for data analysis, not for learning the basics, that for or following the traditional way of programming, that is start from core basics and then spending long time in basics and then moving to data analysis. They were really excited to jump directly on data analysis. So this was something very interesting I found out. And parents were the biggest motivating force. So most of the students we taught were asked or motivated by their parents to join these classes and learn data analysis as a skill. So we should not forget the role of parents if we are trying to introduce this in the schools. And last but not the least, visualization is the favorite part of data analysis for both kids and adults. We offered a boot camp on only the data visualization techniques in Python, and it was a very popular course. So this is something where a lot of time should be spent. And the last part is we can engage with community using data analysis tools. So this is how we can engage with community by solving community problems. So again, when I say that we have to pick our data, formulate some problems, then these are, I've given some examples on some kind of problems which can be solved or which can be addressed. Where should the parks be located? What are the traffic hotspots? Or what are the nearest health services for a particular type of health condition? So by picking relevant data sets, we can try to answer some community problems. And this is something which can be done by using the New York City open data sets. And we should remember the role of parents. And the best thing they can do is helping kids understand the problems of relevance to the community. They can engage kids in his discussions where they discuss these kind of problems, or not only the problems, they can also discuss on why this is important. So that is why parents should always be kept into loop by creating awareness and by making them understand why it is important. And the next thing is you don't have to be an expert. Okay, so now I'm summarizing my results, and my most important and point popped up first. So data science education is very important, as we have seen it by examples and by reading reports. And it can be learned and taught with small focused effort and minimum cost. There is there are not high cost involved in introducing it. By that I mean it can be started in schools by collaborating with experts, because a teacher might have to get trained, or or they can collaborate with university and educational institutions who have experience in running these kind of programs. And it's really easy to start because the existing infrastructure can be used, like teachers, computer labs, Chromebooks, the infrastructure or the things that are already being used in the school. We can just use them and start data science curriculum or data science workshops, however you want to do it. And the last and the most important thing is you don't have to be a data analyst expert to teach. So we need good teachers to teach data analysis. We need, for learning, you have to find an appropriate resource. But for teaching, you need good teachers. You don't have to be an expert. So an expert in data analysis or or a data analyst expert not necessarily be a good data, say, data analysis teacher. So we need good teachers, but we can do without expert data analyst. So thank you. Thank you for attending this event. And you can always contact me for questions, comments, or suggestions if you have. My email ID is viserllc@gmail.com. And I'm going to share a feedback link. Let me know, see if it is already shared. Okay, let me share this feedback link. I would appreciate if you share the feedback. So before you go, let me Let me stop sharing and then I'm going to give you a link, back link. Just give me a second. So this is a feedback link and I would appreciate, thank you for attending this event. It was my pleasure meeting with you all. Thank you.